आज के इस प्रीमियम एक्सप्लेनर में आपका बहुत बहुत स्वागत है। टुडे वी आर डाइविंग डीप इनटू द एब्सोल्यूट सीक्रेट्स ऑफ विजुअल स्टोरी टेलिंग। वी आर गोइंग टू लर्न एग्जैक्टली हाउ टू टेक बोरिंग chaotic data tables and transform them into powerful beautifully clear charts. Get ready because we are literally going to take raw numbers and turn them into insights you can process in a split second.
Here's a quick roadmap of our journey today. We'll be breaking down pie charts, building bar charts, learning how to sort with Pareto charts, comparing nominal versus ordinal data, and then wrapping it all up with a final summary. चलिए शुरू करते हैं.
Section 1. The pie chart breakdown. Visualizing the share of a pie.
So, let's start with our very first visual transformation. When you think of a pie chart, I want you to literally picture a freshly baked pizza. The whole pizza represents our entire data set, right? 100% of our data. And every single slice or wedge represents a specific category's share of that whole. If someone eats half the pizza, well, that visually proves they took 50% of the total pie. It is the absolute perfect tool when your main goal is to show the share of a category.
ध्यान से देखिए, imagine you're looking at a raw data set. This right here is our starting point, our input phase. We've got 4 categories, A, B, C, and D, sitting right next to their relative frequencies in decimals. Category A is 0.40, while the rest is 0.20. As just raw text, it's a bit dry and hard to picture, isn't it? Let's process this.
Here is the exact magical process to transform that text into a chart. Pehle step mein, we identify the relative frequency. Let's take category A, which is 0.4. Dusre step mein, we multiply that exact decimal by 360 simply because a full circle has 360 degrees. 0.4 multiplied by 360 gives us exactly 144 degrees. And the final step? We just draw that resulting 144-degree angle as a bright wedge inside our circle.
And boom, here is our beautiful output. This modern donut chart does the exact same job as a traditional pie chart, just with a really stylish hollow center. And it brilliantly illustrates our math. That orange slice for category A, it takes up exactly 40% of the visual space, which is that 144-degree angle we just calculated. Without reading a single number, your eyes tell you instantly that category A completely dominates the data.
Let's apply this to a real-world scenario. Imagine working in a super busy hospital, and somebody hands you this raw text distribution of blood groups for 30 people. It's just a wall of text. Finding the most common blood type requires you to literally scan every single row, compare the percentages in your head, and then try to hold that information. Honestly, it's mentally exhausting and completely chaotic.
Ye dekhiye jadoo. The absolute second we map this over to a visual donut chart, it instantly organizes all that chaos. The visual slices immediately communicate the true story. You instantly see that massive chunk of others, and right next to it, the prominent slice for A positive. This right here is exactly why we use pie charts. It's all about giving the audience an immediate, entirely effortless understanding of proportions.
Moving right along to Section 2, building a bar chart, where we display distinct frequencies.
Now, sometimes we really don't care about the whole pie. We don't need shares. We just want clear, raw counts. Enter the bar chart. Now, the technical definition says it displays distinct values on one axis and frequencies on the other. But let's simplify that. Just imagine standing identical boxes next to each other. The taller the box, the higher the count. And remember, depending on the specific story you want to tell, these bars can rise vertically from the bottom or stretch horizontally from the side.
Take a look at our new input data here. Notice a major difference? Instead of percentages or relative frequencies, we are now looking at raw frequency counts. Category A has exactly 4 items. Categories B, C, and D have exactly 2.
Watch how these bars rise straight up from the horizontal axis. Category A shoots right up to the number 4, while the rest stop perfectly aligned at 2. So the absolute most crucial point here is that every single bar has the exact same width. The only thing changing is the height, which perfectly matches those frequency counts. It's clean, it's distinct, and it makes comparing counts incredibly easy for anyone looking at it.
Section 3. Sorting with Pareto charts to organize for instant insights.
लेकिन क्या होगा अगर हम इन bars को अपनी मर्जी से rearrange करें? Let's say an education board releases the number of students who passed in different geographical regions. Northern has 8,000, Western 6,000, Eastern 2,000, and Southern 1,000.
Now, if we just plot a standard bar chart based on a totally random region order, it honestly looks like a jagged, messy city skyline. Mathematically, sure, this chart is 100% correct. But visually, it forces your viewer's eyes to bounce up and down, searching for the winner, then searching again for the runner-up. It makes the viewer do all the hard work, and we don't want that.
To fix this exact problem, data scientists use what we call a Pareto chart. Honestly, think of this as a complete superpower for data analysts. Instead of random placement, a Pareto chart purposefully sorts the bars in descending order. It highlights the biggest factors immediately, ensuring the most important information hits the viewer the very second they look at the data.
Just look at this transformation. By simply arranging the bars from tallest to shortest, it becomes instantly, totally obvious that the northern region dominates. It forms this really smooth, downward staircase. You don't have to search for the highest or lowest anymore. The chart is literally doing the thinking for you.
Section 4. Nominal versus ordinal data. When order actually matters.
Okay, wait up. Before you go sorting every single chart into a pretty downward staircase, I need to give you a serious warning. Sorting is powerful, but if you don't understand the underlying nature of your data, sorting can actually ruin your visualization. Vian Digi. Let's carefully distinguish these two terms. On the left, we have nominal data. These are just names, things like regions, northern, eastern, or blood groups. There is literally no natural mathematical order to them. You can shuffle them around freely. But on the right, we have ordinal data. This data has a natural, strict logical sequence. Think of t-shirt sizes, small, medium, large. You absolutely cannot just shuffle these without causing mass confusion.
To see this in action, let's look at our final input dataset. We just have a simple tally of 20 students and their requested t-shirt sizes. 7 students ordered small, 8 ordered medium, and 5 ordered large.
Now, notice something a bit different here. The absolute tallest bar is actually sitting right in the middle. Even though medium has the highest count at 8, we did not sort this into a Pareto chart. We kept small first, medium second, and large last. Why? To strictly respect the natural, logical progression of the sizes.
And that brings us to an absolutely golden rule of data science. Seriously, burn this into your memory right now. Never sort ordinal data into a Pareto chart. Always preserve the natural, logical order. Imagine if you presented a chart that read medium, small, large, just to make the bars form a downward staircase. Your audience would be completely disoriented. Logic must always overrule aesthetics.
Section 5. Wrapping up our categorical displays.
You've successfully leveled up your visual skills. Remember, you use pies and donuts for proportions, bars for raw counts, and Pareto charts for sorted insights, but only when your data allows it. But I'm going to leave you with one final thought. Visuals are incredibly powerful, and because of that, they can be manipulated. Next time you see a beautifully sorted chart in the news or in a corporate report, put on your new data science lens. Ask yourself, is this nominal data, or are they hiding a natural order just to cleverly change the narrative? Keep questioning the data, keep visualizing, and thank you so much for joining this explainer.